Hi there, welcome back. In this video we're going to take a look at Java's ArrayList class. As you'll see, lists play a big role in computer programming. As you can see, I'm using SketchUp again as an environment in which to explain this new topic of array lists. Let's start out over here. Here we have a screenshot of Amazon.com's website. And as you can see, Amazon organizes information. In this case, I did a search in all departments for Java, and Amazon has returned a list, really. You could think of these almost like objects, right? List of objects about each element in the list is an object that tells about a particular thing that Amazon book or something that Amazon has available on the subject of Java. So the information is organized by lists of books or tapes or DVDs or something. This concept of organizing things by lists is extremely common. Here we have, iPhoto, screenshot of iPhoto. In this case, the list is, presented sort of across and down, but the same concept of we have a list of objects. In this case, each object is a photograph or an image, because photograph is not really the right word to use anymore, but a digital image. Here we have YouTube. Again, a list of videos in this case. Start to see how common this is. Here we have Google. A search for Java has returned a list of web pages where you can find information about Java. Finally, iTunes. And here we have a list of music. But notice that iTunes also provides lists of lists. So in this case, we have a list of 90s music, list of my top rated, recently added, etc. So lists can become quite complicated. They can be nested, and they can be sublists of sublists, etc. But the basic concept of using lists to organize things is so prevalent that it would be really surprising if Java didn't introduce a structure for handling lists, or if a Java course didn't introduce a structure for handling lists fairly early in a programming course. And that's what we're going to do right now. So we have a few things here. We have some Java code from your book with the comments stripped out just to tighten up the code so that we can fit it in a reasonable amount of space. We have a graphical representation of a Java array list. And we'll get into this in detail. But in just a second, we have a couple of objects here, which are string objects. And so the string objects have this green box. We'll get into what this is in just a second. So let's look at this in a little more detail. So this array list, is what's known as a generic class, meaning that we have to specify what type of object we're going to put in the generic class inside these angle brackets. So in this case, we have an array list of string objects. We might have an array list of digit objects going back to the Chapter 3 exercise, or we might have an array list of any type of Java object. But whatever that type is would be placed inside of the angle brackets. Then the name for this particular array list is supplied by the user. In this case, we're calling it words. So this is an array list of string objects called words. Okay, let's look at a bit more closely at the array list itself. Notice that each box or element or index position of the array list is numbered. The numbers start at 0. This is true from in almost all programming languages. Lists of whatever type, if they're indexed lists, that is if each box has a number, the numbering starts at 0. And each element of the list, of the array list, contains, in actuality, it contains an address, right, which I've represented here as a bunch of 1s and 0s. So this would be an address of some location in the computer's memory. We don't particularly need to worry about where that is, just that if an element of an array list has a reference to an object, what it really has is an address of that object, where that object is in memory. Now, for convenience sake, in your book, and here, we represent that binary number address as an arrow, right? So this cell position points to an object. So in this case, it's this cat string. And sorry, pausing because of that interruption. But I don't know whether you heard that. There was a phone call. We'll just go on. Okay, so we have this cat object, this cat string, which is referenced from this array list position. Right? There's not really a blue arrow inside your computer, but it just helps visually to understand that. Array lists have a field called size, which tells us how many of the elements in the array list are occupied. In this case, one of the array list elements is occupied. So that field is called size, which is actually called size, has a 1 in it. Okay. What are these orange bars about? Well, it's sort of a convention that if an empty array list position, if you're representing it graphically, it's drawn with a slash, diagonal slash across it. What that diagonal slash stands for is null, which is Java's built-in value for nothing. So an array list by default, when it's created, has all of its cells set to null until objects are actually added into those, or references to objects are actually added into those cell positions. Then they no longer are null, right? So in this case, if we were to add this this object, the string object that uses the word dog, into the array list, in essence what would happen is that would be removed, and this is not quite right because the dog object would have been already created in memory somewhere, but we're going to just move it up here. That's where that dog object happened to be. And so now we have a reference to the cat object at position 0 in the array list, and a reference to the dog. It's not really a dog object, it's a string object with the word dog in it, and a string object with the word cat into it. Now I need to make one more change here. Some of you have probably already guessed what that is, right? So this is no longer 1 here. There are now 2 objects referenced in that array list, right? And there would actually be, what would actually be contained in here is an address where the string object containing the word dog is located. We'll just put that there as a representation of reminder that that's actually what's in that box, right? But from our point of view, what's important is that if we access the one position of the array list, we can get to dog. Okay? A couple more things before we go and look at the code. Array lists cannot have any holes in them. In other words, you couldn't have this blue arrow coming from the 2 position and this position being null. It's all the elements, all the occupied elements of an array list need to be on the left, and then all the null elements are to the right of that. There are no null elements stuck in between occupied elements. Very important concept, a very important fact that that's the way an array list works. Okay? So now let's come and look at this code. Let's see. Okay, so this is class notebook. It contains a private array list called notes. So, you know, this could be notes instead of words. I just used words here. This is how an array list is created. So in the field, we define a variable field. In the field area, we define a variable field that will hold a reference to an array list of strings. In the constructor, we actually make a new array list of string, and we store that, a reference to that, in notes. Okay? So imagine we have some variable, some box out here called words, and that variable contains a reference to this entire thing. Right? And when the array list is created, all the cells of it, again, contain null. Okay? And here's how you add something to the array list. In this case, we have a mutator method called storeNote, which gets in as a parameter note. And in here, we use the method of the array list class called add, which will add a note into notes. Okay, that's exactly equivalent of what we did with adding dog to the array list. Right? If we want to get the size of the array, or sorry, not the size of the array list, but the number of elements that are stored in the array list, which is different from the size, we call the accessor method of the array list class size, and what do you think that returns? Whatever's in this field of the array list class. So in this case, it would return 2. Okay. And here's the command to get the object that's stored in a particular note location. It's the word get, and followed by parentheses, some variable that will evaluate to an index position. So with our example, if I did notes.get1, it would return, that would return a reference to the dog object, or the string object that contains dog, and then we could feed that into the println method, and it would output dog. Okay? Oh, while we're here, an important, somewhat important fact is that Java will, when you create a new array list, if you do not specify a size, which you could do if you wanted to, but if you just leave that blank, the default constructor for an array list will create an array list with 10 elements, numbered 0 through 9. Now, if you filled up all of those elements, and there were blue arrows coming out of all of these boxes, and you did another add to the array list, Java will automatically add more cells. You don't need to worry about that. But it does it, at least the first increment is 10. I have to check and see what the next increment is. It might be another 10 and then another 10. I'm not sure about that. This is not terribly important at this point, but you could treat it as kind of an interesting bit of trivia right now. Finally, the if this were my class and I wanted to call this method store note from another class, or let's say another method within the notebook class, the way I would do that is I would, in this case, it would have to be from within this. Say I've added a method to this class because there's no object dot notation here, so this would only work if it were within the notebook class. But I would call store note, which is this method. I would pass in the string object that I'm storing, in this case cat, and then the store note method would add cat to the notes array list. Okay? So it's really not much more complicated than that. As you practice by writing programs, I think you'll quickly get the hang of array lists. As a reminder, right, lists are really important in computer programming because we as humans love to organize information in terms of lists. Okay, that's it for now. Thanks.